Hi all, welcome to another session from Nairo Research, and in this session I'm going to brief you how we can perform the calculations of periodic energy decomposition analysis in our band interface. I'm Srijit here, so let's start the session. So the in the last video I have briefed you about what is PEDA and what are the important theoretical concepts, and in this video I'm going to show you that how we can set up a calculation. So this is actually an example of a carbon monoxide on a metal surface of magnesium oxide. So how we can do the input setup for this specific calculation. So just I'm opening up a new input and I'm using the details from this tutorial, periodic energy decomposition analysis, from the band tutorials from SCMWeb, and I'm copying this coordinates and I'm just pasting here in this interface. So you can see the coordinates have been pasted, and now we need to set up this calculation. So before that we need to model the regions. I'm just changing it to the model tab. I'm just taking the region. So now why this thing has to be selected for exclusively setting up the fragments. So first I'm just selecting the CO carbon monoxide fragment and just select it, and I'm renaming it as CO, and then I'm just selecting the rest of the fragments and I have given it as MG. So this is the way which we select the necessary fragments, and after that we are just going to the multi-level in the panel bar, selecting the fragments and just checking the use fragments option, and then we are going back to the main panel for setting up the calculations. First one we will be focusing on exchange correlation function, GGA PBE, and then the basis set, of course, DZP. We need to perform a little bit higher order calculation, and the frozen core small, and then a little bit normal numerical quality we need to change to basic. So this is just to make the calculation a little bit faster for producing better result. And we cannot use numerical quality to be normal in the case of faster calculation. And now we can see the input, the single point energy calculation has been done, everything has been set up, and now we will save it before executing. Save as some PEDA batch. So I have already done the calculation earlier, so it will take some time. For time being, I'm going to show you that what will be the result. So let me go back to that calculation. So this is actually the input which we have already generated, and let me show you what is the output. So just I will show you the output. So from the output file, we can go to properties and we can see the PEDA energy terms. So in the previous video, I have briefed you what are the different energy terms that can be added to find out the PEDA energy. So it will be Pauli, electrostatic, and orbital interactions, which covers the main energy, bond energy terms. So this is actually the output of the calculation, which is related to periodic energy decomposition analysis. And also there is one more term which we need to analyze. So that's, I will show you the visualization through AMS movie. So here in this view, so I'm just using the view, and from here I'm just adding the isosurface with face to show you that how this adsorption can be briefed. And then I'm just focusing out fragment related densities, deformation density with respect to some of the fragments. It will take some time. So it is using this interactive cube to run the calculation, which we have already calculated the field. And after finishing the field calculation, we can see that what is the exact output. So now I'm going to adjust this parameter here. So now you can see that how it looks like, and this would be the expected output of periodic energy decomposition analysis for this carbon monoxide molecule on a magnesium oxide surface. So in the next video, I will be briefing the scientific side of this, how this can happen and what are the terminologies behind this observation. So thank you for now. We will see you in the next video. And for more information, I request you to kindly subscribe our channel, and also requesting you to follow our LinkedIn page. Thank you.